jump. So, Austin and Keenan point out a very good fact, right? The ability of an explicit formula is that it allows you to jump to any term without having to go through and list all the previous terms. Oh, you can do almost anything with it. It's not just multiplying, addition, subtraction. Okay. Well, let's take a look here. What it is allows you to jump. So we define any nth term. It's going to have to do with the variable n, which is the number of terms. So let's take a look at the first example. We got -2, 2, 6, 10. What is happening? Brandon?
Adding 4.
Adding 4, right? Okay. Brandon says we're adding 4 every time. All right, guys, if you're adding 4 every time, this is really simple. Whatever you're adding or subtracting by, that becomes your coefficient. So we got a sub n. It's going to be 4 times n. So that, whatever you're adding or subtracting by, that becomes your coefficient. Now we got a problem, though. Okay, now we need to problem solve and think a little bit more critically on this. If I put 1 in, right, because this is term 1, term 2, term 3, and term 4. Okay, what's 4 times 1?
4.
What am I supposed to get? -2. How could I adjust or tweak that formula to give me the -2?
8 sub n equals 4 n
minus 6. All right, so if we look at the 4 minus 6, we ask ourselves, okay, so does that work for everything? So now we got to go back and double check that. So go to the second term. 4 times 2 is 8 minus 6, 2. Does that work? Okay, well, let's try it again for 3 just to make sure. 4 times 3, minus 6, 6. So there's your explicit formula. All right, let's look at the next one. Now, this one's a little more tricky. Okay, now, guys, I'm not going to lie. These are going to get very tricky, very difficult. So we got -5, -2, 3, and 10. What's happening every time?
You're going up by odd numbers.
Going up by odd numbers, so +3, +5, 7. All right, so now, guys, anytime that you're not going up by the same amount, that means you're probably going to have some type of exponent involved. You might want to make a special note of that. Anytime that you're not going up by the same amount, it's going to be an exponent. So that probably means we're going to have an n squared somewhere in there. So we got a sub n is something n squared. I'll do a plus or minus. Okay, so let's start playing around with this. See what we can come up with. Okay, so remember, this is term 1, term 2, term 3, term 4. So, what's 1 squared? Blaine, say with me.
1.
So how do I go from 1 to -5? Subtract what? 5. 6. All right. Now, guys, again, I might be wrong. So you always want to go back in and try it again. So now what's 2 squared? 2 squared is 4 minus 6 gives us -2, so that matches. Okay, now I'll try 3 squared. 3 squared is 9 minus 6 is 3. Okay. Brandon, did you have a question? Okay, so that's basically like what I look at as kind of tweaking the formula. Okay. I start off with n squared, and I look at my first term being 1. So I say, okay, well, what's 1 squared? 1. How am I going to get from 1 to -5? So then I would subtract 6. And then I see if it works right. And if it does, then that's your formula. All right, so guys, let's take a look at the next page here. Okay. So Kylie, I want you to describe that formula for me, that pattern. What's happening on example 1? Okay, so we're subtracting 3. Perfect. So Lindsay, give me the next term of that sequence. 68. Good. Okay, Devin, what comes after 68? 65. Ivan, explain to me what's happening in number 2.
They're going up by, or you're multiplying by 4.
Okay, so we're multiplying by 4. Okay.
By 2. Multiply by 2.
Hold on, what?
Times 4 is 16
times. What are we actually doing, guys?
Gosh!
Multiplying by 2. I can't believe you guys let that one go.
I can't believe I'm running your pen.
Oh, welcome to math class, Austin.
I'm even paying attention.
All right, Kayla, what comes after 64?
She's Googling.
Yeah, use your calculator.
120.
Kayla?
Oh,
That's okay if you want to use a calculator. I'm all right with that. 128, really good. Christian, what comes after 128?
256.
56. So those of you guys that deal with binary, those two numbers should not be that surprising twice. Okay. All right, number 3. And I'm going to walk you through number 3, and we'll put you in charge of number 4.
You gotta walk this.
Okay. Number 3 says write a recursive formula. Yeah, what is the framework, right? This is going to be this template we're going to do for recursive. Every recursive formula starts with what? A sub what? Sub n. Okay. Now, first of all, describe to me what's happening here with number 3. What are we doing? We're adding 1 to the previous term, right? So, how would I represent that with the recursive formula? A sub n equals A sub n minus 1. So that's the previous term. And what am I doing to that previous term? Adding 1 with, now what's my starting value? With A sub 1 equal to negative 2. Alright, let's take a look at number 4. Okay. Patrick, describe to me what's happening at number 4. Subtracting by 5, okay. So, Callie, help me out here. How do I start this formula? Okay. Minus 5. And why are we putting the minus 5 there? Because we're subtracting 5 every time. Okay. With. Alright, so Tori, what's my starting value? There we go, guys. That's recursive formulas. Right? They're not super scary, are they?
I don't like it when they show their teeth.
Okay, let's take a look at number 5 and number 6. Alright, Cole, what's happening at number 5? Adding 3. Good. Now, Amber, what type of formula are we trying to find? Trying to find the explicit. Okay, so again, guys, that's allowing us to jump now with an explicit formula. We're still going to be writing it with an A sub n. Okay, now since we're adding 3 each time, since you're going by the same value, what does that become? What do we call that? Remember we saw that earlier. Becomes the coefficient. So we get 3n. Okay, what does that work? Just a sub n equals 3n?
No, sure.
Okay, what do we need to do to tweak that, Brandon?
The plus a sub 1. Yeah.
Okay, well, a sub 1 is 4. So if I go 3 times 1, that gives me 3. Ladies, how do I get from 3 to 4?
Plus 1.
Add 1. Okay, now check your formula, make sure that works. Okay, if we plug in 3, what should our outcome be, right? If I look at the third term, what should be my outcome? 10. So what's 3 times 3? Plus 1 is 10. So there's our formula. All right, what's happening on number 6? Sorry? Error, so we're not going by the same value, are we? So what do we do then? What's that? If we're not going by the same amount every time, what does that imply? Exponents. So what are we going to start with? Probably let's start off with an n squared term. Okay, so we look at first term, second term, third term, fourth term, and fifth term. So plug in 1. What's 1 squared? 1. How do we go from 1 to 2? Okay, now let's see if that works. Let's try 4. What's 4 squared? 16. 16 plus 1 is? So does that work? No. Alright, so guys, we're looking at this. Again, for your homework tonight, you're going to have to find the next couple of terms in a sequence. You're going to come up with explicit formulas and recursive formulas. Okay? So as you are going to have to learn how to use the subscript feature on Math Excel.